Hello friends, in this video we are going to discuss the dynamic characteristics of SCR during turn-off. Okay, so here we are having the plot for the dynamic characteristics of the SCR during turn-off. Okay, so it is a plot between VA and IA. Okay, so as this is the dynamic characteristic during turn-off, means initially our SCR is in the on state and we are interested in turning it off. Okay, so first of all let us discuss how to turn off the SCR. Okay, so for that recall the definition of the holding current. Okay, what is the holding current? It is the minimum anode current required to maintain the SCR into on state, otherwise it will turn off. Okay, so how to turn off the SCR? The first thing is, yes, first of all we need to reduce the anode current below to that of the holding current value. Okay, so this is the very first step. Okay, very first step we need to do. Okay, so whether only reducing the anode current value below the holding current value, is it sufficient to successfully turn off the SCR? No, it is not sufficient. Why? Because now we are going to discuss what is the reason behind it. Okay, so suppose, as we know, the SCR is a PN device, right? So it is a 4-layer and 3-junction device, P, N, P and N. So P, N minus P and N. SCR, it is a anode, it is a cathode, and here it is a gate terminal we are having. Okay, so next, when SCR is in the on state, so it is like we have connected the external supply Vs and here it is a load. Okay, so when SCR is in the on state, what will be happening? Yes, all the junctions J1, J2, J3, these 3 junctions will be acting as a short circuit, and here it is a short circuit. Okay, so when SCR is in the on state, all the 3 junctions will be acting as a short circuit, right? So when SCR is in the on state, yes, what happens? Yes, the current will be flowing from positive plate of the supply towards the anode of the SCR, and through the body of the SCR it will be flowing and again return to the cathode of the SCR and the negative plate of the supply. Okay, so when SCR is in the on state, the current will be flowing in this loop. Okay, but as we know, what is this? This is the EMF, electromotive force. This source consists of positive charges at one side, negative charges at the second side. Okay, so if the current is flowing like this, yes, can we say that the positive charges will be moving or entering into the body of the SCR? Yes, no, right? So positive charges will be entering into the body of the SCR in this way. Similarly, here in the EMF body at the negative plate we are having the electrons. So definitely the electrons also will be moving in this direction. Okay, so here electrons will be entering into the body of the SCR. Okay, so when SCR is in the on state, the positive charges as well as negative charges will be flowing through the body of the SCR. Okay, and from where those charges came? Those charges came from, yes, the source itself, the source itself. Okay, so if you check initially when we purchase a SCR from the market, okay, before biasing, yes, what we observed in the SCR body across each junction, that is a J1, J2, J3, there was a formation of the depletion layer. Okay, but now when SCR is in the on state, whether the depletion layers are present here? No. Okay, so the depletion layers are not present. Okay, so here next, in order to successfully turn off the SCR, okay, so suppose if we by any way, if we make anode current is equal to 0, okay, suppose we reduce the anode current to be equal to 0, okay, means ultimately I have disconnected the SCR from the supply. Okay, so only disconnecting the SCR from the supply is sufficient? No. By disconnecting it, what will happen? Yes, definitely the IA become equal to 0, right? Once we disconnect the SCR from the supply, the anode current will become equal to 0. But only disconnection is not sufficient. Why? Because if we only make the anode current is equal to 0 or anode current less than the holding current value, and if we again apply the forward voltage, then whether our SCR will be able to block that forward voltage? No, SCR will not block that forward voltage. Please, I am repeating it. I am repeating the statement. Please try to understand it. Okay, so very first step is, suppose for making the anode current less than the holding current, so holding current value is very small, generally it is in the range of milliampere. Okay, so here we are keeping or we are making IA to be equal to 0. Okay, how we have made IA is equal to 0? Simply we have disconnected the supply from the body of the SCR, okay, or from the SCR. Okay, so when we disconnect it, and again if we apply the forward voltage across the SCR, suppose I have disconnected it, and now suppose again I am applying the next forward voltage across the SCR, our SCR will not block that forward voltage. Why? Because in the body of the SCR, yet there is a at the body of the SCR near to the junction, yet the depletion layers has not been formed. Okay, means expected is here we need to form the depletion layers. Once the depletion layer forms across each junction, and after that if we apply the forward voltage, then definitely our SCR will block the voltage. Okay, so what is the missing thing? Yes, here we need to form the depletion layers across junction J1, J2 and J3. Okay, but how to form the depletion layer? Okay, how to form the depletion layer? So for that, yes, when the SCR is in the on state, when SCR is in the on state, at that time the large number of charges, large number of charges were injected into the body of the SCR, that is all the 4 layers of the SCR, from the supply means supply is nothing but it is a source which consists of the positive charges as well as negative charges. So when SCR is in the on state, yes, from the positive plate the holes are injected into all the 4 layers of the SCR. Similarly, from the negative plate the electrons are injected into all the 4 layers of the SCR. Okay, means here all the 4 layers consists of, all the 4 layers consists of the added charge carriers, right? Now, so we need to remove those added charge carriers, right? From where those added charge carriers came in the body of the SCR? Yes, the added charge carriers came from the source only, okay? So when SCR is in the on state, from source, the added charge carriers will be added into all the 4 layers of the SCR, okay? So only by making IA to be less than the holding current value, it is not sufficient to make the SCR to be able to block the forward voltage. Okay, so for that case we need to remove the added charge carriers. For that we need to remove the added charge carriers. So what are the added charge carriers? If you check the in the p-type layer, the added charge carriers are holes. In the p-type layer the added charge carriers are holes. In the n-type layer the added charge carriers are electrons. In the p-type added charge carriers are holes, right? And similarly in the n-type the added charge carriers are electrons. Okay, so here we are having the added charge carriers in all the 4 layers of the SCR. Okay, so suppose here we are having 1000, 1000, 1000 and 1000. Okay, in each layer, suppose from the source, right, we are having the 1000, 1000, 1000, 1000, means in each layer we are having the 1000 charge carriers, more charge carriers, okay, have been added into all the 4 layers of the SCR. Okay, so how to remove the added charge carriers? Okay, so before formation of the depletion layer we need to remove those added charge carriers. Okay, so how to remove it? So for that, yes, we need to maintain the reverse voltage. We need to maintain the reverse voltage across the SCR. We need to maintain the reverse voltage across the SCR. Okay, so if we maintain the reverse voltage across the SCR, what will happen? Here we are having the electrons, here we are having the holes. Okay, and here the added charge carriers are in the upper p-type layer, we are having the holes. Okay, so these holes will be attracted towards the negative plate of the supply, right? Because at the negative plate we are having the electrons, so definitely these holes will attract towards the negative plate of the supply. Similarly, whatever the added charge carriers are there in the outer n-type layer, okay, so these electrons will get attracted towards the positive plate of the supply. Okay, means we can remove the added charge carriers from the outer 2 layers of the SCR by maintaining the reverse voltage across the SCR. By maintaining the reverse voltage across the SCR. Are you getting the point? I am repeating it again. This is a very important point, right? Very important point. So before moving towards the characteristic, yes, we are discussing how to turn off the SCR. Okay, so very first step to turn off the SCR is, first of all, make anode current value to be less than the holding current value. Okay, so for that I have disconnected the supply from the SCR, but only the disconnection of the supply from the SCR is not sufficient. Why? Because if after disconnection, if I again apply the forward voltage, yes, our SCR will not block that forward voltage. Okay, SCR will continue into the on state. Okay, why SCR is going into the on state again? Because here the depletion layers has not formed. Okay, depletion layers have not formed. Okay, so for the formation of depletion layer across J1, J2, J3, we need to first of all remove the added charge carriers from all the 4 layers. Okay, so from where the added charge carriers came into the all the 4 layers of the SCR, the added charge carriers came from the supply only, right? Means when SCR was in the on state, okay, so whole side electrons were added into all the 4 layers of the SCR. Okay, so how to remove the added charge carriers? Yes, so for removing the added charge carriers from the outer 2 layers, yes, we have connected the reverse voltage, right, across the SCR. We have maintained the reverse voltage across the SCR. Okay, means here the added charge carriers from outer 2 layers, yes, we can remove those charge carriers by maintaining the reverse voltage, across the SCR, right? Next, how the added charge carriers from the inner 2 layers can be removed? Yes, from the inner 2 layers, the added charge carriers will get removed by recombination. Okay, means here we are having the junction J2, it is acting as a short circuit now, right? Okay, so whatever the added charge carriers are present into the inner 2 layers, those charge carriers can be removed by recombination. Okay, means one electron from the N type and one hole from the P type, they will recombine with each other. Okay, and they get neutralized. Okay, so in this way we can remove the added charge carriers from the all the 4 layers. Okay, so very important point. Okay, so first thing is we need to reduce the anode current less than the holding current value. Second thing is we need to remove the added charge carriers from the all the 4 layers of the SCR. Okay, in that, how to remove the added charge carriers from the outer 2 layers? Added charge carriers from the outer 2 layers can be removed by maintaining the reverse voltage across the SCR. How to reduce the added charge carriers from the inner 2 layers of the SCR? For that, yes, added charge carriers from the inner 2 layers will get neutralized by recombination, or will get removed by recombination. Okay, so here in this way the added charge carriers can be removed. Okay, so once the added charge carriers removed from the all the 4 layers, after that what happens? Yes, we are having the SCR PNPN device, which is similar to that of whatever we have purchased from the market, right? Whatever we have purchased from the market. Okay, means indirectly after removal of added charge carriers from all the 4 layers, yes, now there will be the formation of the depletion layer across junction J1, J2 and J3. Once the depletion layers have been formed, and after that if we apply the forward voltage, then definitely our SCR will block that forward voltage. Is this clear to all? Are you getting the point? Okay, so very important point. Okay, so first thing is, first of all we need to reduce the anode current to the less than that of the holding current value, and second thing is we need to maintain the reverse voltage across the SCR for some time. Okay, and what is that time we are going to discuss. Okay, so next, so now coming towards the characteristic. Okay, so as I said, this is the turn off characteristic during turn off. Okay, so means our SCR is in the on states, right? So when SCR is in the on state, what is the voltage across the SCR? It is the on state voltage drop, right? So are you getting the point? This voltage is nothing but on state voltage drop. This is the on state voltage drop, and this current, it is a on state current which was flowing through the SCR, right? Now, in order to initiate the turn off process, in SCR, right, we have started decreasing the anode current by any means. Okay, means by any arrangement we have started decreasing the anode current, because very first step is we need to reduce the anode current value to the less than that of the holding current value. Okay, so for that case we have started decreasing the anode current value. Okay, so next, here if you check, at this instant the anode current becomes equal to 0. Okay, now when anode current is 0, only making the anode current to be 0 or less than the holding current value, is it sufficient? No, anode current is 0 means what? Definitely it is a less than that of the holding current value. Okay, so only making the anode current to be equal to 0 ampere is not sufficient to successfully turn off the SCR. So for that case, we are going to maintain the reverse voltage across the SCR. Okay. So when we maintain the reverse voltage across the SCR, at that time what will happen? Yes, from the upper p type layer and the lower n type layer, right, the charges will be moving towards the reverse voltage or towards the external battery, which we have connected in the reverse bias for the SCR. Okay. So therefore the current flowing or the flow of the current will be in the anti-clockwise direction. Flow of the current, if you check, so here we are having the PN device, right, PN and N. Okay. So we have connected the reverse voltage across the SCR. Okay. So when reverse voltage is connected, how the current will be flowing? Current will flow like this, that is in the clockwise direction. Okay. So IA actual direction was like this. Okay. So if we maintain the reverse voltage, so IA goes negative. Okay. So here that's why the IA is in the negative. Okay. So what about the voltage across the SCR? Yes, voltage across the SCR is a VAK. Voltage across SCR is a VAK, right? So this voltage is also negative. If you check, this voltage is also negative. Okay. Now suppose we are having here 1000 charge carriers are present in all the four layers. I am saying it is a 1000, right? For example, suppose we are having the added charge carriers in all the four layers is equal to 1000 in each layer. Okay. In each layer we are having the 1000 charge carriers. Okay. So as soon as the reverse voltage is maintained, what will happen? Yes, all of a sudden all the positive charges from p type will try to move here, all the negative charges from n type will try to move in this direction. Okay. So that's why the current goes on increasing. Okay. Now suppose out of the 1000, suppose around 600 or yes, around 600 charge carriers have been removed. Okay. Means now what is the number remaining? Yes, we are having suppose only 400 present here. 400 charge carriers are present here. Okay. So here we are having the 400 charge carriers. Okay. Here we are having the 1000. Here it is also 1000. Okay. So only 400 and 400 charge carriers are present now, because out of the 1000, 600 charge carriers suppose removed. Okay. So if you check, when here we were having 1000 charge carriers, here also 1000 charge carriers, at that time the rate of flow of charges, if we compare that rate of flow of charges with now here we are having 400 charge carriers, so that's why from here also the charge carriers will try to move here, the charge carriers will try to move here. But if we check the rate of flow of charges, in which case the rate of flow of charges will be more? In the first case it was more. Okay, that is a 1000, means all of a sudden 1000 charge carriers will try to move towards the respective plates of the battery. Now after removal of the 60% charge carriers, means now we are having the 400 charge carriers present, means 40% are present. Okay. So if you check the rate of flow of charges here, definitely it will be lesser than that of the previous case. Okay. So here the current is increasing. Okay. So almost 60% of the charge carriers gets removed. Okay. Then after that what will happen? The current goes on decreasing. Okay. So it indicates this, right, from here to here. Okay. So we are having the removal of the charge carriers, right? So similarly the voltage is also we are having the negative, means we are maintaining the reverse voltage during this interval. We are maintaining the reverse voltage. Okay. So till this instant almost all the added charge carriers from the outer two layers have been removed. Okay. So that's why this time interval is known as the reverse recovery time. TRR stands for reverse recovery time. TRR means reverse recovery time. What is the reverse recovery time? It is the time required for removal of added charge carriers from outer two layers of the SCR, by maintaining the reverse voltage across the SCR, Okay. Next, so after removal of added charge carriers from the outer two layers, now yes, the added charge carriers from the inner two layers, these charge carriers will get neutralized by recombination. Okay. So this indicates TGR. TGR is a gate recovery time. Right? Gate recovery time. Okay. What is the gate recovery time? It is a time taken or time required for removal of added charge carriers from the inner two layers by recombination. Are you getting the point? Is this clear to all? Okay, TRR means reverse recovery time, TGR means the gate recovery time. TRR is related with the removal of added charge carriers from the outer two layers by maintaining reverse voltage. TGR, that is the gate recovery time, it is associated with or related with the removal of added charge carriers from the inner two layers by recombination. Okay, so next, so this TQ is equal to TRR plus TGR, right? I am writing here TQ, that is a device turn off time. TQ is a device turn off time. Okay, and TQ is equal to TRR plus TGR. TQ is a TRR plus TGR. Are you getting the point? Okay, so reverse recovery time plus gate recovery time. Okay, next we are having one more time, that is a TC. TC is a circuit turn off time. Circuit turn off time. Okay, TC is the circuit turn off time. Circuit turn off time means what? It is the time measured from, it is the time instant measured from, yes, the instant at which anode current is 0. It is the time instant measured from the instant at which anode current is 0, and the reverse voltage is maintained across the SCR, right? Reverse voltage is maintained across the SCR, right? So from this instant till the reverse instant, right, is nothing but your TC. Okay, TC is the circuit turn off time, and for successful commutation means the turn off. Okay, for the successful turn off of the SCR, yes, TC should be always greater than TQ. For successful turn off, of SCR, yes, TC should be greater than TQ, greater than or equal to, right? TC should be greater than or equal to TQ. TQ means device turn off time. The device turn off time value is generally given by the manufacturer. Okay, who gives the value of TQ, that is the device turn off time? The manufacturer of the SCR, right? And who gives the value of TC? The TC, that is the circuit turn off time. This value will be decided by the design engineer. Okay, because TC depends on the circuit parameters. Okay, okay. Next, while studying the rectifier, after that the inverter, chopper, etc., we will discuss what is the TC. You will understand what is the TC. Are you getting the point? Okay, so very important, how to turn off the SCR. In order to turn off the SCR, the very first step is, first of all, reduce the anode current value to be less than or equal to holding current value, right? Anode current should be less than the holding current value, less than equal to. Okay, next, second thing is, we need to maintain the reverse voltage across the SCR for the time TC, that is the circuit turn off time, for the time TC, which is greater than or equal to TQ. Okay, so we need to maintain the reverse voltage. Why we are interested in maintaining the reverse voltage? Because we are interested in removal of added charge carriers from all the 4 layers. From where those added charge carriers entered into all the 4 layers of the SCR? From the source, right? How? When SCR is in the on state, means when SCR was acting as a short circuit, at that time the added charge carriers, right, were entered from battery, that is the source positive plate and the negative plate, right, into the body of the SCR. Okay, so in order to make the SCR to be able to block or SCR to be successfully turn off, we need to remove those added charge carriers. So for that, for removal of the added charge carriers from the outer 2 layers, we need to maintain the reverse voltage across the SCR, and for removal of added charge carriers from the inner 2 layers, right, they will be removed by recombination. Okay, they will be getting neutralized by recombination. Okay, so this is about the dynamic characteristic of the SCR. Okay, TRR plus TGR is equal to TQ, device turn off time, TC, circuit turn off time. Okay, so in the next video we will discuss the numericals based on this concept. Thank you.